Hi guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So for the final topic, we're going to talk about Biomolecules Survey Part 4 on nucleic acids. So nucleic acids are biopolymers or large biomolecules that are essential for all known forms of life. So nucleic acids, which include DNA and RNA, are made from monomers known as nucleotides. And now I'm going to start off with a very brief history of how these guys came about. And so in 1869, Friedrich Mischler isolates nuclein from white blood cells. And then in the early 20th century, nuclein was found to consist of three fundamental components. And you can probably guess what these were, right? So the first one was a phosphoric acid. And then the second was a carbohydrate. And this was in the form of either D-ribose or 2-deoxy-D-ribose, which is this sugar right here. And finally, it involved a heterocyclic base. And when I talk about a heterocyclic base, a heterocycle means that it has at least one ring which includes an atom other than carbon. So when we look at these heterocyclic bases, we have the nitrogen, which is a part of the ring, which is not carbon, and thus these are called heterocyclic. So basically, they found that there were three components of this nuclein that they found, and it composed of the phosphoric acid groups, the sugar, which was either a ribose or deoxyribose, and finally a base. And the base took on the form of either being purines, such as adenine and guanine, or being pyrimidines with only one cyclic ring, such as cytosine, uracil, and thymine. So then in the 1920s, they came up with the term nucleoside as the combination of carbohydrates and a heterocyclic base. So this was called a nucleoside. And in this case, the heterocyclic base, nitrogen, was bonded to the ribofuranose anomeric carbon. So in this case, we have the base right here, and the nitrogen was bonded to the anomeric carbon right here of the ribofuranose. And in the case of the carbohydrate, if it was a ribose, then you had ribonucleic acid, or RNA. And in the case that this sugar was a deoxyribose, then you had deoxyribonucleic acid, or DNA. So the next definition that came about was nucleoside plus phosphoric acid gives us nucleotides. And so this is a nucleoside with a phosphate on the 3' or 5' carbon. So now looking at this diagram, we have the base that is bonded to a sugar via a glycosidic bond, and then we have one phosphate group, which makes it a nucleoside monophosphate, but if it had another, it would be nucleoside diphosphate, and finally, if it had three phosphate groups, it would be nucleoside triphosphate. So they figured out this as the structure of the fundamental building block of life.